Earth is the only known planet in the solar system where life exists. It's home to a vast diversity of species, including 8 different human species and countless animals, which is astonishing. Despite discovering over 6,000 planets, none have been found to support life like Earth. This planet, with a diameter of 12,742 kilometers, is the largest rocky planet in our solar system. In contrast, Jupiter is the largest planet in the solar system, capable of holding 1,300 Earths, which is incredible. However, despite its enormous size, Jupiter is insignificant when compared to the vastness of the universe. If we compare Jupiter's size and mass to the Sun, Jupiter seems like a speck of dust beside a mountain. The Sun, with its massive diameter of 1.4 million kilometers, is a true giant among stars. To grasp its scale, more than 1.3 million Earths could fit inside the Sun's volume. But that's not all. An astonishing 99.8% of the entire mass of the solar system is concentrated in the Sun alone. Its immense gravitational force binds the planets, asteroids, and everything else in the solar system together, creating the cosmic balance we live in. If the Sun were to shift its position or be influenced by some unimaginable external force, the entire solar system, Earth included, would be dragged along, held captive by its gravity. We are inextricably tied to this stellar giant. The Sun is just one of septillions of stars scattered across the universe, a number so incomprehensibly large that it's written with 24 zeros. Every star is unique, each contributing to the vast cosmic tapestry. Within our own galaxy, the Milky Way, there are over 500 billion stars of varying sizes, colors, and lifespans. Yet among all of them, one stands out as the largest known star in our galaxy, Stephenson 2-18. This colossal red supergiant is mind-boggling in its scale. At 2,150 times the size of the Sun, it dwarfs our star to an almost insignificant point. To put that into perspective, if the Sun were the size of a human, Stephenson 2-18 would be the size of a large stadium, large enough to swallow over 2,000 suns within its diameter. But the universe always has bigger surprises waiting to be uncovered. Stephenson 2-18 may hold the current record for the largest known star, but astronomers believe that even larger stars could be lurking in the farthest reaches of space. In fact, the early universe once hosted stars that were even more massive than anything we can observe today. These stars were known as quasi-stars, and they were true cosmic monsters, measuring up to 7,100 times the size of the Sun. Imagine, if you will, the Sun shrunk down to the size of a bomb. It would still pale in comparison to the sheer enormity of these quasi-stars. A single quasi-star could contain the mass of hundreds of suns, but these quasi-stars were not just giant balls of gas and fire. They played a crucial role in the formation of one of the universe's most mysterious and powerful objects, black holes. Deep within the core of these quasi-stars, black holes were born. As these quasi-stars consumed vast amounts of matter, their cores collapsed under their own gravity, giving birth to black holes of unimaginable size. These primordial black holes continued to grow over billions of years, feeding on gas and stars, until they became the supermassive black holes that we see today at the centers of most galaxies. Our own galaxy, the Milky Way, is home to one such supermassive black hole, known as Sagittarius A star. This titanic black hole has a mass equivalent to 4 million suns. Despite its relatively modest size of 26 million kilometers in diameter, only about 18 times the size of the Sun, it possesses the gravitational pull to eject entire stars from the galaxy at blistering speeds. The sheer mass of this object categorizes it as a supermassive black hole, a fitting title for something with the ability to warp space and time itself. But black holes and quasi-stars only scratch the surface of the universe's wonders. The more we learn, the more questions we have. What lies beyond these tunnels? Are there stars or black holes even larger than we can imagine, lurking in the unseen corners of the universe? As technology advances, telescopes like the James Webb and other future instruments will continue to reveal the secrets of the cosmos, offering glimpses into the most colossal and mysterious objects ever to exist. The universe, with its seemingly infinite size and potential, still holds countless mysteries, and we are only just beginning to understand its vast complexity. But this is just the beginning. Let's move on to even more mind-boggling black holes. TON 618, a quasar located 18 billion light-years away, was once considered the largest black hole in the universe. TON 618 is an ultra-massive black hole with a radius of 1,300 astronomical units, AU, which is equal to the distance between the Earth and the Sun. Its total diameter spans 2,600 astronomical units, or approximately 3.9 trillion kilometers. This black hole is 80 times the distance between the Sun and Neptune, and its mass is 10,000 times heavier than that of Sagittarius A, the black hole at the center of our galaxy. If we consider the volume of TON 618, it could hold the stars of entire galaxies within it. It's about 11 times the size of our solar system, and it takes light 14 days to cross from one end to the other. That's how immense this black hole is. But if TON 618's size impresses you, its brightness will astound you even more. It shines with the light of 1,400,000,000,000 suns. If TON 618 were as close to us as the Milky Way, Earth would never experience night. Yet, even the mind-boggling TON 618 is overshadowed by another colossal black hole. Deep in the Phoenix cluster, situated a staggering 8.61 billion light-years away, lies a black hole so immense that it redefines the boundaries of cosmic comprehension. The Phoenix A galaxy, the heart of this cluster, is 6 times larger than our Milky Way, and at its core lurks a black hole so vast that it stretches across 3,900 astronomical units, AU, or an unbelievable 5 trillion kilometers. To put that into perspective, this black hole could comfortably fit 17 entire solar systems inside it. What's truly astonishing is that this black hole is 1.5 times the size of TON 618, a scale that challenges the very laws of physics. According to current scientific models, such a massive black hole shouldn't even be possible, yet the universe, with all its mysteries, continues to surprise us. If you were to lay Earth-sized planets across its width, it would take 4.57 million Earths to stretch from one side to the other. Even using black holes the size of Sagittarius A, the supermassive black hole at the center of the Milky Way, you'd need an astounding 22,500 of them to match the diameter of this unfathomable monster. But it's the mass of this black hole that truly boggles the mind. It weighs in at over 100 billion times the mass of our Sun, accounting for roughly 10% of the entire mass of our galaxy. Imagine a black hole with more mass than some galaxies combined. It defies every theory we have about the universe. Traveling across it at the speed of light would take almost a month, an incomprehensible distance for even the fastest thing in existence. This is no ordinary black hole. It's a supergiant formed when a star too enormous to die collapses under its own gravity, creating an object of such incomprehensible mass that it rivals entire galaxies. In some cases, galaxies like Phoenix A even merge, giving birth to even larger black holes. These form clusters known as large quasar groups, LQGs, bound together by the gravitational force of these titanic black holes. One of the largest LQGs ever discovered, the huge Large Quasar Group, HLQG, spans an unbelievable 4 billion light-years and contains 73 quasars. Its sheer size is beyond human understanding. To grasp just how enormous this is, consider this. Phoenix A's massive black hole is dwarfed by the HLQG. You could fit more than 64 Phoenix A-sized black holes inside the HLQG, and there would still be room left over. Located 9 billion light-years from Earth, this quasar group has a mass 40 times that of the Milky Way and is 30,000 times larger in size. To draw a comparison, if the Milky Way were the size of a football, the HLQG would be the size of an entire small city. This comparison highlights the unimaginable scale of these cosmic structures. The HLQG occupies 4.5% of the observable universe, which is staggering. Even larger than galaxy superclusters, these quasar groups hold thousands of galaxies, including our Virgo supercluster, which is 11 billion light-years across. The Virgo supercluster is part of the even larger Laniakea supercluster, which stretches across 52 billion light-years. But even these massive structures pale in comparison to the largest cosmic structures, the galaxy filaments. These filaments are vast networks of galaxies and superclusters. In these filaments, our Milky Way and the Andromeda Galaxy are mere specks, like particles caught in a cosmic web. These filaments are the largest structures in the universe, and I'll compare them in the next part of this video. For now, this video covered the comparison of supermassive black holes and how incredibly large the biggest black hole in the universe is. Let me know which part of the video surprised you the most in the comments. Thanks for watching, and I'll see you in the next one.